Good morning everyone, and welcome to the new series in cybersecurity. In this series we are going to discuss about the interview questions that will be asked to candidates in the cybersecurity field. We are going to look at multiple options over here, and we're going to discuss various fields in which these questions will be asked. In this video we are going to look at 10 different questions on networking, then we'll have 10 more questions on software and programming, another 20 questions on operating systems and applications, 10 questions on cyber attacks, and then finally 10 questions on cryptography. So we're going to discuss over 50 odd questions each in these different fields, which will help you crack your interviews as far as cybersecurity is concerned. Let's start off with networking questions. Let's start off with question 1. What is the OSI model? Explain the different layers of the OSI model. OSI largely is a theoretical model utilized to understand networking and how data packets are created and how they are being processed by a computer. This is normally used by the TCP/IP, the Transmission Control Protocol over Internet Protocol software suite. So OSI is known as the Open Systems Interconnection Model. It is a reference model that describes how applications are going to interact via the computer network. There are 7 different layers that we need to understand. They are as follows. So in this diagram, there are these 7 different layers. We start off from the bottom. First is the physical layer, the data link layer, network layer, transport layer, session layer, presentation, and application. When such a question is asked in an interview, it is not only that we identify these 7 layers, explaining what the OSI model is in the first place, we then try to identify these 7 layers and we give a brief description about each and every layer. If there are any additional questions, they will come after this basic question. So let's start off with the physical layer. This is the lowest layer of the OSI model. Now this is where any and every physicality of your computer comes into the picture. So it could be a network interface card, it could be an RJ45 or a Cat5 cable, anything that allows data to be transmitted physically from your machine to another machine. Next comes the data link layer. So on the data link layer, as far as networking is concerned, we just need to understand that data packet is encoded, decoded into bits at this layer. This is also the layer that deals with MAC addressing. So the physical address of every network interface card, which is the MAC address, which is utilized to route data packets over the network. This is where the MAC address resides, on the data link layer. The next layer is the network layer. Here datagrams are transferred from one to another. The function of this layer are routing and logical addressing. The moment we talk about routing and logical addressing, IP addresses come into the picture. IP version 4, IP version 6. So network layer will deal with IP addressing and the routing of those packets. Then comes the transport layer. This is the layer responsible for end-to-end connections. That automatically signifies that this is where TCP and UDP will be working. TCP stands for Transmission Control Protocol, UDP for User Datagram Protocol. TCP is a connection-oriented protocol, whereas UDP is a connection-less protocol. These two protocols are utilized to establish connectivity between two machines. TCP is a more reliable method of connectivity because there are a lot of packets that are sent across to verify that the data has been sent, data has been received, and so on and so forth. Whereas UDP is a connection-less protocol where data is just dumped without verifying whether the receiver actually receives that data or not. So in a nutshell, on the transport layer, TCP and UDP make their appearance, and this is where that functionality lies. Then comes the session layer. This controls signals between the computer. It establishes, maintains, and terminates connections between processes. So in the transport layer, we talked about TCP and UDP. UDP being a connection-less protocol where data is just transmitted without verifying whether the receiver received that data or not. Whereas TCP, we studied, is more of a reliable protocol. Thus, there are different packets, signals that will be sent across to verify that data has been transmitted, it has been received properly, and then the next segment of that data is being sent. So those control signals are established using the session layer. So the three-way handshake of TCP, the acknowledgement packets, and those kind of packets will be taken care of on the session layer of the OSI model. Then comes the presentation layer. The presentation layer is responsible to translate data into the application layer format. So the formatting, right? MIME or encoding that is being utilized, the UTF-8 character set that we utilize for presentation, encryption mechanisms, all of these work on the presentation layer. And finally comes the application layer, where the application itself uses a particular protocol so that the other machine on the receiving end, the application on that machine will be able to understand what the communication was about, right? So in a nutshell, if I start from up top, the application layer will deal with any of the data that the application is generating. So maybe a user input, you're logging in, you're typing the username, password, all that data will be constructed, let's say, into an HTTP or an HTTPS format. That's where your application layer comes into the picture. Then the formatting of which into UTF-8 and the encryption of which would be done at the presentation layer. Then this transport layer and the session layer would kick in to establish a TCP session, do the three-way handshake, establish that connectivity. IP addressing would be done on the network layer, MAC addressing would be done on the data link layer, and when everything is ready on the physical layer, the packet will be sent out. At the receiving end, the packet will be received on the physical layer, and then all these layers will be reversed, and finally at the application layer, the data would be presented to the application, who would then execute it and showcase it on the screen of the recipient. So this is the way you want to explain this question. You want to be very concise, precise about what you're explaining. You don't want to go into too hypothetical scenarios. You don't want to dilly-dally with the layers. You just want to give the basic functionality, want to demonstrate that you understand what the OSI layer is, how the computer functions, and you want to move on from there. If the interviewer has any further follow-up questions, they will ask those specific questions. So that's question 1. Moving on to the question 2. Question 2 is define unicasting, multicasting, and broadcasting. Now this is a question which can be very lengthy, but again, most of your interview questions are designed that way. It's basically to understand how much conceptually you are aware about these technologies. So you have to be very concise. Don't go rattling about technology too much, but in a concise manner, just try to explain what these things is. So when data is being transmitted over a network, it can be transmitted either in one of these particular manners. It can either be a unicast, multicast, or a broadcast. So what is unicast? Unicast is when a message is sent from a single user to a single receiver. So one to one, right? So one machine talking to another machine and nobody else. So also known as point-to-point communications. One point to another point. If you have to send information to multiple receivers, then you will have to send it using multicast, right? So this is where your multicast networking comes into the picture. So in our case, let's assume it's a network where there's a class C network, approximately 255 odd machines. And within these, there are two machines that want to talk to each other. If they want to talk between each other, it would be a point-to-point communication where they will utilize unicast, where only these two machines will have visibility of that conversation and the other machines will not even realize that this conversation is taking place. If one machine wants to talk to multiple machines, then the multicast comes into the picture. As the name suggests, in this mode of communication, data is sent from one or more sources to multiple destinations. Multicast uses the Internet Group Management Protocol, also known as the IGMP protocol, to identify groups. So under this IGMP protocol, various groups are created where machines are subscribed to those particular groups. And whenever a message needs to be sent through those groups, it will be identified by the IGMP protocol, and then that particular message will be sent to those multiple machines that are members of those particular groups. And then comes the broadcast. The third method is known as the broadcast. As it says, it is going to broadcast to all. So this is one to all, that is communication between a single user, and it is going to be sent to all the machines in that particular network, right? So the three ways: unicast is one to one, multicast is one to many, and broadcast is one to all. Then question number 3. What is DNS? DNS stands for Domain Name System. It is like the internet's phone book that is responsible for mapping the domain name into its corresponding IP address. And let me give you an example over here. Whenever we go and open up, let's say, a browser, a Google Chrome browser, we type in www.google.com and then we press enter, and magically Google comes in front of us, the website rather. Now, how does the computer know who Google is? Because as far as we are concerned, humans understand Google and words like that. Computers don't. Computers deal with binary, zeros and ones, right? And as far as internet is concerned, they will only deal with IP addresses and MAC addresses. So how does a computer know how to find google.com and where is it located? So the moment we type in the browser window, in the address bar, google.com and press enter, a DNS query is generated automatically by the browser, where a packet is sent to our DNS servers asking what the IP address is. So in short, DNS resolves domain names to their corresponding IP addresses. There is a DNS server which will have this index, a database of all the domains associated with their IP addresses. If one particular DNS server does not have that information that you're looking for, it may query another DNS server who may have that particular response. So the first thing is, when you type in domain name, it gets resolved with the DNS. It identifies the IP address corresponding to that particular domain name and thus allows the computer to route that packet to the particular server where that domain name resides. So in this scenario, if you look at the screen, on the local PC, you have typed in cybersecurity.com. There is a DNS resolution, that a query that goes to the DNS server. What is the IP of cybersecurity.com? The DNS server looks it up in its particular database. If it has the corresponding IP address, it will then respond back. The IP address is 172.17.252.1, after which the packet is sent off to cybersecurity.com. Moving on to question number 4. What is a firewall? Now, this is a very good question, and normally a very basic answer that I've ever heard is that a firewall is a hardware and a software firewall. But that's the functionality of a firewall. That is how you can install a firewall. But there are different types of firewalls, and there is a specific functionality that a firewall is created for, right? So a firewall is either a hardware or software, but its responsibility is for blocking either incoming or outgoing traffic from the internet to your computer. They secure a network. So essentially, the firewall will allow a connection to happen or disallow a connection to happen. It won't go beyond that. That's the basic functionality of a firewall. Okay. So based on the configurations that you have done, based on the rules that you have created on the firewall, it will then, based on those rules, identify whether some traffic is allowed in that network or some traffic is to be blocked from entering that network. So as the screen shows, the firewall rules will analyze whether the traffic is good. If yes, it will allow. If the traffic is bad, it will block the traffic and not allow that connection from happening in the first place. Now, there are a few common types of firewalls that also need to be included in the answer to this question. And the first one is a packet filtering firewall. These are the most common types that you will come across, which analyze packets and lets them pass through only if they match an established security rule set. Now here people do get confused when we say that we analyze packets. People think that these firewalls will analyze the contents of that packet, which is not correct. When a definition for a packet filtering firewall says that these firewalls analyze packets, it means that they are only analyzing the source and destination IP addresses, port numbers, and the protocols that are mentioned in those packets. These firewalls do not have the capability of deep packet inspection, or DPI as it is known. If that capability comes into the picture, you're basically looking at an intrusion detection system or an intrusion prevention system in today's world called as a next-gen firewall. Okay, so a packet filtering firewall essentially will only analyze data packets for its source and destination IP addresses, port numbers, and the protocol that is being utilized. It will then map that information to the rules that are there on the firewall. And based on those rules, it will either allow that connection to happen or disallow that connection from happening. The second type is a proxy firewall. These firewalls filter network traffic at the application level. So when you say application level, they work at the layer 7 of the OSI model. Packet filtering firewalls, since we have mentioned that they worked on IP addressing and port numbers, will work on the network layer of the OSI model. Also on the transport layer, because they also look at protocols. Proxy firewalls will work at layer 7, which is the application layer of the OSI model, and will deal with application level protocols such as HTTP, HTTPS, FTP, SMTP, and so on and so forth. And the third one is a stateful multi-layer inspection firewall. These filter packets at the network, transport, and application layers. So they basically do the job of the first and the second type of firewalls. The packets are compared to known trusted packets. But now the first question is, if there is a stateful multi-layer inspection firewall, why do we have type 1 and type 2 firewalls like packet filtering and proxy firewalls? That is because that is how the firewalls have evolved. We started off with the packet filtering, then we added functionality to it, and so on and so forth. So if a question comes, what is a firewall? You start off with the option saying it is a hardware or software. This is the responsibility, the functionality of a firewall is to allow good traffic and disallow bad traffic based on the rules that have been configured on the firewall. And then you've got basically three types of firewalls: packet filtering, proxy, and stateful multi-layer. And just include a brief description of each of these firewalls.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Then moving on to question number 5. What is a VPN? VPN is also called a virtual private network. It is a connection between a VPN server and a VPN client. So it basically creates an encrypted tunnel between the client and the VPN server, which is then utilized to secure the connections that you're making with the internet. So as you can see in the diagram, the user has a VPN client installed on their machine. The VPN client then creates an encrypted tunnel to the VPN server. And through this tunnel, encrypted data is transmitted, which can then be processed by the VPN server, sent to the internet. Information can be received back by the VPN server. The VPN server will encrypt that data back and send it back to the user. So if there is a man-in-the-middle attack that is happening, or a hacker trying to eavesdrop on the communication mechanism, they will not be able to do so because of the encrypted tunnel. It is very difficult to decrypt this or hack through this encrypted tunnel. It is possible, but it is very difficult to achieve that. Moving on to question number 6. What are the advantages of distributed processing? Now, before we go into advantages of distributed processing, we first have to understand what is distributed processing. So it is a term which describes various computer systems that use more than one processor to run an application. Here, multiple computers across different locations share the same processor. The advantages of distributing processors are as follows. But before we go into the advantages, distributed computing is basically where multiple machines will pool their resources together to run a singular application. So an application that has multiple resources and can scale up and scale down as and when required. The advantages are that it can be very useful in data recovery. For example, RAID, where you're striping data on various hard disks. It is reliable, it is cheaper, lower cost can be achieved, and it is easy to expand because of the scalability factor that we just talked about. If there is loss of data in one computer, it can then be recovered by another interconnected computer. And one of the examples would be blockchain in today's world, right? What is blockchain? That this data is created live and stored on a connection of computers. So if one of the computers goes offline, the other computers in that network will still have that data, and the blockchain will still function without any issues. The second point, a glitch in one machine does not affect the processing, as there will be multiple other machines like we discussed in the blockchain. Several cost-effective mini computers are used instead of costlier mainframe machines. So instead of having a server bank, I can have multiple machines interconnected together, and they can function in that particular blockchain or for that particular distributed processing mechanism. Depending on the amount of data processing, more computers can be attached to the network. Thus, you can increase the number of computers that can be a part of that blockchain, or you can reduce them as and when necessary. Moving on to question number 7. What is TCP/IP? TCP/IP, or Transmission Control Protocol over Internet Protocol, is a set of communication protocols that are used to interconnect networking devices on the internet. This protocol defines how data should be transmitted over the internet by providing end-to-end communications. So essentially, if you want networking to be established on your machine, you will need TCP/IP. Without TCP/IP, there will be no work groups, there will be no domains, basically your interconnectivity will go for a toss. TCP/IP is a software that once installed on your machine will then interact with the hardware, which is your network interface cards, and then your switches, wires, cables, and all those through protocols that have been already pre-configured in it. So within the TCP/IP suite of softwares, you will have all the protocols, all the functionality of the OSI layer, and each and every protocol that works on each and every layer will be predefined and pre-configured to work in a particular manner. The Internet Protocol is all about routing each individual packet to make sure it reaches its destination. So with the TCP, you're talking about the protocols that will allow you to format the data and generate it so that you can communicate it over the network. The IP will then deal with the routing of those packets so that the packet can be routed to the correct computer and be received by the recipient. So the TCP/IP model is the compressed version of the OSI model. The 7 layers will get converted into 4 layers: the network access layer, internet layer, transport layer, and application layer. Going on to question 8. What do you mean by ipconfig and ifconfig? Both of these are commands, the first one on a Windows machine, the second one on a Linux machine. So ipconfig is known as the Internet Protocol Configuration. This is a command that is used on the command line interface of Microsoft Windows to view all the adapters and the configuration of each and every adapters for their network interfaces. So as you can see on the right hand side in the command prompt screen, if once you type in the ipconfig command on the C prompt and press enter, it will give you a list of all the adapters that are there. So you can see wireless LAN adapter, local area connection, the media is disconnected, it doesn't exist. At the bottom you will see the Wi-Fi connection, wireless LAN adapter, and it can give you the IP version 6 IP address, IP version 4 address, the subnet mask, and the default gateway. So this is the configuration that allows the machine to know on what network it is on, what is the default gateway for communicating to the internet, what is the subnet mask, so how many computers may exist in that particular network, and what is the IP address of that specific computer so that it can communicate across the network as well. ifconfig is the same thing on a Linux, Mac, or Unix operating system. So the command will also give you the list of interfaces and the configuration of each and every interface. It is used to configure, control the TCP/IP network interface parameters from the command line interface. It allows you to see the IP address of these network interfaces. So here you can see the WLP19S, the IP address being 192.168.43.215, subnet mask being 255.255.255.0, with the broadcast being 192.168.43.255. Question 9. What is the difference between a domain and a work group? This can be a very interesting question and can be a very lengthy question at the same time. A work group is nothing but a decentralized network where you have interconnected multiple machines together and each machine acts in its own individual capacity. Thinks of itself as a server, right? So a decentralized network, every user manages the resources individually on their PC. So local users on their own PCs managing the network shares, what can be shared from that particular machine, what data should be shared, should not be shared, to whom it can be shared with, and so on and so forth. It is good if you've got a small network, a few machines altogether, and you want them to interact with minimal management effort, right? So each computer, each user will decide what they want to allow other users to see on that particular network. And all of them would be connected over a LAN, a local area network, either a wireless or a wired one. So if you look at your home Wi-Fi right now, that is one of the best examples of having a work group. The domain, on the other hand, is a centralized network model. So in a corporate environment, whenever you go there and you got a domain-based username and password, which when entered onto a particular machine gives you access to the entire network or whatever applications and whatever resources have been allocated to you, that is where the domain comes in. So it also uses a single sign-on mechanism for all the resources that are to be made available to you. Whereas in a work group, you're a local user only meant for that particular computer, right? So coming back to the domain, it is an administrator who's going to manage the entire domain and all of the resources connected to the domain. The resources could be switches, routers, servers, data stores, applications, web servers, mail exchange servers, and so on and so forth. So all of these are administered by an administrator through the domain. It is the most reliable and the optimum solution for a large network where multiple users are going to interconnect and share that data amongst each others, right? The computer can be connected to any network. That means you can be on the internet, and through the internet using a VPN, you can connect to your corporate network, authenticate in, and get access to whatever resources you are allowed to access. Whereas in a work group, you have to be a part of that network to access that particular network. If you change your location, you go and connect to another Wi-Fi, you will lose access to your previous Wi-Fi. Then the last question for the networking section: what is data encapsulation in networking? Data encapsulation refers to the process of adding headers and trailers to the data. The data link layer binds each packet into a frame that contains the hardware address of the source and the destination computer. So in this example, when you're talking about data encapsulation, we have talked about how data that has been created by the application layer would have a header and a trailer that will give the various informations of where that data needs to be sent. So the hardware address, which is the MAC address, comes into the picture and gets added to the header, and the IP addresses, port numbers, and all of those things would then be added to this trailers as well, so that the data can be then routed to the intended recipient of that particular communication. With this, we end the first 10 questions in networking, and in this video we are going to look at software and programming. So we're going to look at the first 10 questions. First question being, how do you keep a computer secure? Now this is going to be a very generic question, so you want to put your best foot forward and you want to identify the most common methodologies on how you can keep a computer secure. So when we talk about computers, the first thing that you want to talk about is authentication mechanisms, where you want multi-factor authentication or two-way authentication to ensure that your accounts are kept secured. Now, if you look at using passwords, depending on how passwords are being stored by the application, password attacks can be possible, either a brute force attack or a dictionary-based attack, or even password guessing attacks are possible. To mitigate those kind of attacks, we need multi-factor authentication to ensure that accounts are kept secure. Now, even if we are using multi-factor authentication, we also want to look at secure passwords, which means that the password is complex enough to withstand most of the common attacks, and a brute force attack or a dictionary attack is just not possible. So we want to randomize our passwords. We want to create a complexity where a password meets standards such as has at least one lowercase, one uppercase character, has numerics and special characters, and is randomized, is not based on a dictionary word, doesn't contain usernames, email addresses, phone numbers, or anything that is personal to that particular user. Third, keep regular updates, which means that there will be patches that will be released for the application, for the software that you're utilizing. Download the patches, install them on a regular basis to ensure that you are secured against the most recent attacks that have been identified. Install a good antivirus. Could be an internet security suite, which will have an antivirus, intrusion detection system, a firewall, and will help you protect yourself against ransomwares, malwares, and any script-based attacks. Also have a specialized firewall on your system. Could be a host-based firewall or a network-based firewall to ensure that attacks are kept at a minimum, and you have your network definitions in place to allow or disallow connections from happening to your devices. Have anti-phishing softwares installed as well to ensure that you are not getting any spam mails. Even if you do, you're able to identify that and not fall prey or victim to those spam mails. Phishing attacks are generic, where they are directed towards individuals and they prey on the gullibility of that particular individual. So our Nigerian frauds or the lotteries that we win on a regular basis of hundreds of $1 million, those messages, the emails that we receive, they are all phishing emails where they're basically prone to victimize the user and then rob them of money or install some malware or do some other malicious activity. If you want to enhance encryption about data that you have stored on your devices or on your or that is accessed by your software or being transmitted by your software, use encryption. Encrypt your data, whether it is at rest, whether it is in motion, or whether it is at use, thus reducing data leakage and data loss possibilities. And finally, and the foremost, secure your DNS. DNS is the domain name server, which is utilized by computers to resolve domain names to IP addresses. if a DNS poisoning attack is possible, where your DNS settings have been modified by an attacker and you're redirected to a malicious DNS server, that server is going to redirect you to another malicious application which may have a malware or a malicious software as a payload. Also, you don't want people to know your DNS servers and the queries that you're making, so you want to use secure DNS or DNS over HTTPS to encrypt your DNS queries as well. So, in a nutshell, if you follow these 8 steps, your devices, your computers, your applications are going to be as secure as possible. The next question: discuss security related aspects between C, C++, and Java. Now, this is an open-ended question. It depends on which level you're giving an interview on, but we're looking at it from a fresher's perspective or a less experienced perspective. And thus, these are some of the aspects that we want to look at and the comparisons between C, C++, and Java. So the 5 aspects that we are looking at are pointers, code translations, storage allocation, inheritance, and overall security based on C, C++, and Java. So when we say pointers, we are looking at how we are going to, we are using pointers and stacks and heaps to point to functions, and how we exit those functions, and how those functions are then recalled into the next function. So C supports pointers, it is most secure. C++ also supports pointers, but it is a little bit less secure than C. Java, it is not supported. Direct access is given to memory allocation, and thus it is the least secure as far as pointers are concerned. When we look at code translations, C is able to compile, but it is not secure. Same with C, C++. But in Java, it is an interpreted language and it is abstracted and secured. In storage allocation, in C, we use malloc and calloc memory allocation, which is less secure because it does not have internal checks on verifying what memory is allocated and the user input that is being compiled or that is being input to that memory, right? Thus, this can allow buffer overflow errors to creep in because of the non-verification of the input data. So it is the least secure. In C, C++, it uses new and delete options and is comparatively secure, but Java uses a garbage collector and thus is the most secure as far as storage allocation is concerned. When we talk about inheritance, the most secure is C, C++. C has no inheritance, so it's not secure. In C++, it is supported, thus it is the most secure. Whereas in Java, there is multi-inheritance that is not supported and thus is comparatively secure. Overall, the most secure out of all these based on these 5 aspects is Java. The least secure is C, and the mid-level is C++. Moving on to question 13. What are the different sources of malware? Now, malware stands for malicious software, right? Malware is basically a software that poses as a legitimate software but has a payload of a Trojan, virus, spyware, keylogger, or some malicious software that is going to have a negative impact on security of your particular device. So the question here is, what are the different sources of malware? We want to identify the most common sources through which malwares infect end user devices in today's world. And we can start with pop-up ads. So most of the websites, if you're visiting untrusted sites, if you're being redirected to sites that you don't know about, there'll be a lot of pop-ups coming your way where it says you're the 1 millionth visitor to this site. Please click here to download your gift. Or it will say, congratulations on winning a particular product for visiting this page, and so on and so forth. There are some instances where you can see a banner which is flashing at you on top of the page and says that there are 8 infections that have been identified on your computer. Click here to download an antivirus to clean the infections. So all of these pop-ups are there as a social engineering attack, as a phishing attack, to make gullible people click on those links and download those malwares. Now, the software that is posing as a security software itself can be a malicious software which is going to install a Trojan or a virus or a bot on your machine, compromising the security of that machine. The second is removable media, USBs. And humans have a fascination with USBs. So if you find a USB lying around, it's a free USB, you get excited about it, and you want to take it home, you want to plug it into a machine and see what's on the USB. Worst case scenario, you format it and you got a free USB to utilize. Higher the capacity, the better. But that is one of the most easiest way people use malwares to be deployed on unsuspecting users. If there is a USB lying around, why would somebody want to forget a USB? It's most likely planted over there as a social engineering attack, so that a gullible person is going to pick it up, plug it into their device. If the device is not secured enough, it is going to install the malware, right? Then documents and executable files. This is where your viruses and all those creeps in. So let's say you're surfing on the internet, you're looking for a software, and you find the software on a particular website. You do not verify the trustworthiness of that site, and you just download and install that software. Now that software could be malware as well. Thus, if you're surfing on the internet, you're downloading files from different locations, you have to research the website, you have to research the source to ensure that it is trustworthy, and only then are you going to download and execute those files. Thus, internet downloads as well. And when we say internet downloads, it's not just untrustworthy sites. We go to torrents, we go to the dark web or the deep web, and we are searching for other softwares, especially those who are researching security, right? We are always on the lookout of new softwares, and we are always on those forums which may not be so much trustworthy, and we just download those files and start installing them. That is a very bad scenario, right? So you have to be very careful what you're downloading from the internet. Your antiviruses, your anti-phishing mechanisms, your threat intelligence mechanisms, have those mechanisms installed, and you want to verify where your downloads are coming from. Then your network connections. If it is a P2P connection, it is a local area network connection or a metropolitan area network, you have to verify which devices are connected to your machines, and you have to validate those connections before you want to trust those devices and before you connect to them. If you're on a public Wi-Fi, you probably don't want to connect to a public Wi-Fi in the first place. Then comes email attachments. There are so many attachments that come across in today's world, most of them in a zip format or a RAR format. Some of them come as document files where there are macros hidden within them. Macros are scripts that are recognized by Microsoft Office files, right? And then finally, there are these malicious advertisements that we find online, right? Let it be Facebook, let it be WhatsApp, let it be any social media platform that you go, or even your search engines. Their job is to display ads. Their job is not to verify whether the ad is legit or not. It is for us as consumers to be careful and validate that ad and verify whether it is a genuine ad or not. So just don't start clicking on any of the ad, trusting the platform that you're on. Be sure that you are investigating that ad. So these are the most common sources of malware, and the end user will always get infected by one of these mechanisms. Moving on to question 14. How does email work? Now, this is a very, can be a complex question, but we have to keep it as simple as possible. And we have to identify that there are two servers, both of them either using SMTP, which is the simple message transfer protocol, where in this scenario, John wants to send an email. Thus, they've got an email client installed on their machine, which is connected to the mail exchange server, which has a DNS server which maps the routing and which maps the exchange server and inboxes. So when John composes that message and clicks on send, John should be connected to a mail exchange server where the email is sent through that particular person's inbox. So John's inbox will then be validated, and that email will then be sent through the DNS server through the internet and will be received by the recipient mail server. So at this point in time, John also requires the recipient's email address. So in this case, this is Jack. So jack@something.com would be the email address. So while John is composing, the to field will have Jack's email address. The from field will have John's email address. The subject field will have whatever they want to convey as a message. The message body will have the message itself. And then when John clicks on send, it will go to their exchange server. The exchange server will then validate the inbox and identify where that inbox is located. for Jack, and then through the internet it will be sent to the mail server of Jack. The mail server will then identify the proper inbox that email needs to be sent to, and it will store that email in that particular inbox. When Jack opens their computer and accesses their inbox, this email from John will be already waiting for them, and they can respond to it the same way John had sent that email.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Moving on to question 15. What are the types of threats a company can face? Right? And this is where your threat modeling comes into the picture. So you're looking at softwares, you're looking at operating systems, and the company comes and asks you, what are the threats that are most likely that a company will face? So on a broader scale, the threats that a company will always face would be classified as natural threats, man-made threats, technical threats, and a supply system threat. So a natural threat would be an act of God which is outside the control of human beings. Could be storms or any natural occurrences like volcanoes, thunderstorms, flooding, earthquakes, fire, and so on and so forth. So anything that is natural. So it depends on the geographic location that you're in and what kind of climate that area faces, and you need to identify the immediate threats and prepare for them. So if it is flooding that you're looking at, and you want to look at an office, and the possibility of the office getting flooded is real, you probably want to take an office at a higher floor so that the threat of flooding is minimized. For fire, we always have a fire drill where we practice our fire mechanism so that we can evacuate all humans as soon as possible and then worry about the technicalities of it. Under any circumstances, under any threats, humans will always have the first priority, and then everything else comes in. Man-made threats are where man themselves are a problem. So strikes, lockouts, hackers, theft, war, rioting, all of those are man-made threats, which we ourselves cannot be in control of, but we need to plan for them, and we need to have a business continuity plan or a disaster recovery plan for any of these threats that have been identified. Then come the technical threats. Technical could be software bugs, operating system bugs, application bugs that come with the applications that we have, or a hardware failure where a server crashes, a hard disk crashes, maybe the processor stops working, the motherboard stops working, RAM gets corrupted. Any of the technical aspects stop functioning, thus creating a break in the business, can come under technical, right? So anything to do with computers, let's say a server failing or a patch that is not installed on a particular software, those would come under technical threats. And then the supply system. The supply system are your environmental threats which depend on your supply chain failures. What is the supply chain? For an office to function, there are a lot of dependencies that an office goes through, right? There are a lot of other vendors that support and provide critical infrastructure, non-critical infrastructure for the office to function. For first and foremost, electricity. Without electricity, nothing is going to be powered on, and you're not going to be able to function. So if there is an electricity service provider, and if there is an electric outage, that comes under supply system. So that's a supply chain failure where the vendor that provides electricity to you has failed in providing that particular service, and now you need a business continuity or a disaster recovery plan. So you probably have an inverter, or you already have a power generator plant that is going to generate your own power and supply it to your system, right? There could be short circuits because of fluctuation in the electricity. Maybe the internet service provider fails and your internet crashes, so you have a backup line for the internet from a different vendor, right? And so on and so forth. Maybe your hardware vendors who are supplying you servers, desktops, laptops and whatnot, they fail because they are facing a strike or they go bankrupt, and suddenly you can no longer purchase hardware from your vendor because they no longer are in business. So that's a supply chain failure. So any of these systems failing would also come under threats. So under a broad category, these are the first 4 threads that you need to identify, and then you can elaborate by providing more scenarios based on the experiences that you have had towards each and every of these threads. So a natural threat where you may have had experience where there would have been, let's say, a flooding or any natural disaster which caused a problem for the continuity of your particular business. So identify each and every example for each of these threads and provide that as an example in the interview. What is black box and white box testing? So when you are testing a software or you're testing your infrastructure, there are 2 different tests that you can conduct. The first one is a black box. The second one is a white box. In a black box test, there is no knowledge that is shared with the tester. So let's say you're an ethical hacker and you have been awarded a contract by an organization to test their current application that they have developed. Now, they are not going to give you any information. They're not going to tell you what the application is. They just probably give you an IP address and a port number where the application is hosted. And now you have to fire in your own queries and try to figure out what the application is, try to gather information, see what information can be gathered in the first place. And based on that, you're going to figure out your way, identify vulnerabilities, and see if any of those vulnerabilities can lead to an security incident. So without any knowledge, zero knowledge of the IT infrastructure or the source code, that's a black box attack or a black box test. A white box test, on the other hand, is where full knowledge of the IT infrastructure or the source code is shared. So the ethical hacker has complete knowledge, and based on the knowledge, they are then going to test out the system to see if there are any flaws that they can identify, right? So why would these 2 audits be important? Because the first one, a black box audit, emulates the attack of an outsider, an external hacker sitting outside the organization trying to figure their way in. Whereas a white box attack can emulate the attack of an insider. So a disgruntled employee within that organization misusing their access controls or their access rights to make unvalidated profits, right? So somebody who's corrupt, who has been bribed, who wants to sell out company secrets so they're going to try to find out vulnerabilities, try to steal data and try to sell it on the gray market, right? So a white box would emulate an internal attack, a black box would emulate an external attack. Moving on to question 17, what is use case testing? Now, use case testing is a functional test and it is also a black box test, right? What is a functional test? It tests the functionality of a particular software once it has been created. Why is it a black box test? Because the user doesn't know what the functionality is. They just want to find out each and every scenario and try to see what that scenario generates as a response. They are not sure whether that is the appropriate response that should be generated or not. They're just trying to find out the response that is going to be generated after they fire off a query. So this technique is used by testers to get the test scenarios to exercise the whole system from start to finish. So let's say it's a login mechanism for an application, right? Now a user at this point in time, the tester, since it's a black box testing, will know that it is a login mechanism. They will not know the details of what logging mechanisms are being utilized. So they wouldn't know whether input validation is done. They wouldn't know whether output encoding is done. They wouldn't know how the CGI calls are being made. They will not know how the queries are handled at the server side and how the database is going to treat that particular query. So they have no idea whether SQL injection attacks are possible and so on and so forth. So for them, with whatever input they are going to try to insert for that login mechanism, that's a functional black box test. The functionality being whether the login mechanism works, and based on the type of inputs that they're going to put in, whether it creates an unwarranted output, whether they can bypass the mechanism or they can hack into the system because of some of the flaws that were left behind, right? Another example here is a software made for users to use for documentation. The testers will test all the cases that the user can do. So can the user view a document? Can they add new documents? Can they edit documents? And can they delete documents? So this functionality will depend upon the access controls that have been granted to a particular user. So for this particular user, the tester at this point in time, they would not know whether they're an administrative user or they're a regular user. They'll just try to do all of these and then write the responses saying, I was able to view, I was able to add, I was able to edit, and I was able to delete. Now, the Result will be then sent to a manager. The manager will look at the results, and then based on the actual access controls that were supposed to be there for this particular user, then we'll try to identify whether this is an acceptable case or whether there were any flaws within this case. Moving on to question 18. What is static and dynamic testing? Now this is again in application testing. Static testing is done in an early stage of development life cycle. Now software development life cycles, there are multiple of those. What are these life cycles? There are different stages in which an application is created and provided to the customer. So your first stage would be determining the scope of the application, determining the hardware requirements for that application, then creating a flow chart for that application, a functional chart for that application, and then maybe start coding. Then an architect comes in, tests the code, verifies the code. Then the testing phase comes in, then the security testing phase comes in, and then the user acceptance testing comes in. But in every stage, at the very earliest of all stage, a static test will always be started to see whatever code has been developed, whatever scope has been developed, whether that scope is going to be correct or not. This will include walkthroughs and code review. What is a walkthrough? A walkthrough is going through documents that have been generated and trying to find faults in the documented journey that has been created so far. So let's say somebody has created a workflow or a flow chart for a program, how the functions are going to be called and how they're going to be executed. So a walkthrough would be where all these responsible people will walk through that particular flow chart and find out any flaws within that and then rectify them. If there is any code that has already been written, this code will be reviewed manually and any flaws within that code would then be identified. Static testing will always be 100% accurate in a very short amount of time because it is immediate. You have created it and then the expert is going to test it to see whether everything is fine or not. Right? It is all about prevention mechanism. So since you're doing it at the inception itself, if you find any flaw, it gets immediately repaired. So this is about preventing vulnerabilities from creeping into that application at a later point in time. Whereas dynamic on the other side is done at the end of the development life cycle. So you have generated the application, everything is ready. Now you want to do dynamic testing. Includes functional and non-functional testing. Functional testing is where the application itself is being tested, the functions to see that all the parameters that are given to the application are functioning properly. Non-functional testing would be where security parameters, administrative parameters, all of them are being verified, right? This is where your test case scenarios come in and you're going to test each and every scenario by generating inputs and analyzing the output that the application is going to give you. Dynamic testing is all about cure. So here you're going to identify vulnerabilities, report them to the management, and the management is then going to figure out a way of patching those vulnerabilities so that they can be mitigated. Moving on to the next question, what are the test levels in software testing? So as far as software testing is concerned, there are 4 test levels: module testing, integration testing, system testing, and the final one is acceptance testing. So in the testing phase of your development lifecycle, the first thing is a module test. You're going to check your routines, your subroutines, your subprograms, procedures that have been written in a program. So all your functions, all your mechanisms for that application are going to be tested. When you go into integration testing, the software may have been integrated with multiple softwares. There may be different API calls coming in, maybe a third-party software on which you're depending upon to supply for information. So all of these integration of various softwares, various APIs are tested to ensure that they are functioning properly and there are no flaws, errors, or mistakes left behind in the integration of all of these softwares. Then the system testing is where the entire system, so including the hardware, including the software, right? It starts from the installation. So now the software is complete. We know which hardware we are going to support for it. We start by installing the software and see whether the installation is going to be completed properly, if there are any errors in the installation process itself. Then once it is installed, the performance of that particular application, the write speeds, the read speeds on the hard disk, the transaction speeds that the application is capable of, the network dependencies that the application may have, all of those would come under system testing. And then the acceptance testing, which is basically a quality assurance exercise that the application meets the client's requirements. So the client in the first stage would have given the scope of what needs to be achieved. In the acceptance testing, you're verifying that that scope has been met and the client requirements have been met, and you can assure the client about the functionality and the performance of that particular application. Coming to the last question in this software programs, what are the valuable steps to resolve issues while testing? So in the previous scenarios where we have started testing, now if you find out, when you execute a particular use case and then you find out a flaw, what would be the steps that you would utilize to address those particular flaws in those tests? The first step will always be record, then you're going to report it, and then you're going to introduce a control process for it. So when you say record, you're going to create logs and you're going to try to resolve all the problems that have happened. Now, when you say resolve, you're not going to recode the application, but you're going to test the system again and again to ensure that whatever is being recorded is accurate, and all the logs, all the error mechanisms, all the dumps, all of those that have been generated due to this particular log or due to this particular error are being captured so that they can be reported to the higher level managers. So the next step is, once you have accumulated all these logs and records, you're going to report them to the higher level managers, who are then going to investigate it and go back to the developers trying to figure out the best way to mitigate those particular flaws. So the report writing needs also needs to be accurate. It needs to be to the point. It needs to detail what the problem was. It will document all the steps that you took, all the inputs that you put in, and it will also record all the errors, and it will also record all the mechanisms that were utilized and the errors that were generated. And that report will be given to the higher level managers, who can then forward it to the developers, who based on those reports can start their troubleshooting. And then the control mechanism comes in. You're going to define the issue management process. So this process needs to work in a particular manner, where you're doing a test, you're recording whatever is happening, you're creating a report out of it, you're sending it to the management. The management will then take those reports, study them, take it to the developers. The developers will test based on their criteria. They might interact with the testers at that point in time to identify particular flaws, and then they might want to recode that application or develop a patch which, once installed, will mitigate that particular flaw, and then it can come back to the testing phase again, where you can repeat those tests and validate that the flaw is no longer existent. So these are the 3 steps that would be utilized for testing purposes. And that brings us to the first 10 questions on the software platform. In the next video, we'll be looking at operating systems and applications. The first question is on virtual memory. What exactly is virtual memory? For a computer, we have 2 types of memory. First is the primary memory, which is your random access memory, which is also known as a volatile memory. And the secondary memory is your hard disk, where your data is stored permanently. But for a computer, when it has, let's say, a 4 GB memory or a RAM, as in this scenario on your screen, it is going to replicate that and is going to create another 4 GB of virtual memory on the hard disk. And it is going to use it in tandem along with the RAM. So if the RAM is insufficient, the processor is going to utilize the 4 GB of the virtual memory that is created on the hard disk, and it is going to swap data from the RAM to the hard disk. This can also be known as a page file or a swap file. The next question is, what are different scheduling algorithms? Now, the context for this question is, you're talking about a processor, and you're talking about how processes are going to be fed to the processor and how the processor is going to treat these processes. So the first is first come, first serve. So the process which requests the CPU first gets the CPU allocation first. Now, whenever there are processes that are being run by different applications, they make requests for some CPU time. Now, in first come, first serve, the first service or the first process that is going to request some processing time will get that much allocated to them. They will run through the process first, and then the next, and the next, and so on and so forth. The second one is the shortest job first. This is the process where the shortest execution time for that process is calculated, and that process is selected first for the CPU. Then there is priority scheduling. This scheduler selects the tasks to work as per priority. So there would be some tasks that are marked with high priority, some would be normal, and some would be low. So based on this high, normal, or low priority, all the processes will be classified. High priority will be dealt with first, then the normal, and then the least priority. The fourth option is multiple level queues, where processes are assigned to a queue based on the specific property like process priority, the size of memory, etc. So it will be classified based on the attributes given to that particular process, and multiple queues will be created, and then based on the attributes the processes will be processed by the CPU. Then shortest remaining time. The process will be allocated to the task which is closest to its completion. So or you look at it this way, the process that will take the least time to complete its processing would be chosen first. And then the round robin method, where each process comes in turn, gets an equal share of time. So if there are 10 processes, each process will be allocated a certain amount of time, after which the next process will be processed, and so on and so forth. And it will continue in a round robin fashion till all the processes get executed. So in short, 6 different scheduling algorithms depending on how the operating system deals with it. The next question is, what are the steps involved in hacking a server or a network? So this is more of an ethical hacking question. You're looking at devices, and the interviewer asks you what kind of steps are involved. What are the activities that you would do in hacking a server or a network? Now, there are no specific steps that you would define, because every hack is going to be unique. But it has a hack can be classified in 5 different steps, which are quite generic, right? So the first step will always be the reconnaissance step, also known as information gathering phase, also known as footprinting or fingerprinting, depending on what exactly you're doing. But in this phase, the attacker gathers all the evidence, all the information that is possible about the targets that they want to attack. So here you're trying to get to know the victim so you can launch specific attacks towards them. You want to identify what operating system they are utilizing, what IP addresses, MAC addresses, the versions of the operating systems and applications, the patch levels, find out vulnerabilities, find out whatever information is possible, find out the information about the person who's using those computers, so you can launch social engineering attacks, and so on and so forth. So the first step is all about gathering enough information based on which you can launch further attacks. Once you have that information comes the second phase, which is known as the scanning phase. This is more of a technical phase. So you have in the first step, you've got your IP addresses, domain names, maybe even network maps, and you have identified which devices are available. Now, in the scanning phase, you're going to identify live devices, and then you're going to scan them for open ports, processes, protocols, services. You're going to identify vulnerabilities. You're going to enumerate them to identify more information from them. Thus, at this point in time, you will have identified a certain set of vulnerabilities or a certain set of security loopholes that you can misuse. Once you have identified those, you're going to the next step, which is the gaining access step. In this, you're actually going to execute your attacks based on the vulnerabilities that you have found, and you're either going to gain access to that particular system by installing a Trojan, or destroy the system by installing a virus, or install a spyware or a keylogger, whatever you wanted to achieve. So in the gaining access phase, you would have, based on the knowledge that you have gained in the first and the second phase, you're going to launch your attacks and you're going to try to gain access to that particular device. Then the next step is where you're going to maintain that access. Now that you have hacked into that device, it is not necessary that you will always be able to get access to that device. Suppose you have cracked the password of that particular user and the user changes that password after a few days. Your attack is worthless. So what you're going to do here is you're going to maintain your access. So this is where it is assumed that you want repeated access to that device, and thus you're going to install a keylogger or a Trojan or some mechanism which will still allow you to get access to that device without the knowledge or the authorization of that particular user. And finally, the last step is where you're going to cover your tracks. So whatever activity that you have done so far will have created logs and will have created information based on which the victim will come to know that they have been compromised and may be able to trace that activity back to you. So to prevent the user or the victim from realizing that they have been hacked, and to prevent them to discover who has hacked them, you want to cover your tracks by deleting logs and any references that point to that particular activity. You're going to hide the files that you have created. So you have installed a Trojan or a keylogger. These will create files and directories. You're going to hide them so that they are not discovered. You're going to hide processes that have been created. You're going to try to hide all the activity that you have done so that to conceal the actual attack and preventing the user from realizing that they have been compromised. So these are the 5 steps that will be involved in hacking a server, network, application, or any computing device you'll come across. The next question refers to what are the various sniffing tools. Now this is a network-based attack where you're trying to capture data packets that have been transmitted over the network, and then you're going to analyze them to see if you can capture any sensitive information like usernames, passwords, bank details, or anything of that sort. Now, these tools would also depend on which operating system you're utilizing. For example, MSN Sniffer would work on Microsoft operating systems. EtherCap would be based on Linux, and so on and so forth. So on the screen, you'll see 6 different sniffing tools that work on different operating systems. Wireshark is something that is common both on Windows and Linux. It is used to analyze network in detail. It is the de facto tool that you will come across in most of your ethical hacking trainings, in most of your organizations when they want to do data captures. Now, data capturing or packet capturing is not only done by hackers to gather more information, but it is also a known troubleshooting technique used by administrators and network administrators to analyze any issues that may be going on in the network, right? So the first tool you see on the screen is Wireshark. Like we stated, is available for Windows, Linux as well. Then there is TCP dump, which again has the same capability of Wireshark, but is a command line version, whereas Wireshark also has a GUI, a graphical user interface. TCP dump is available on Linux. MSN Sniffer, it's a very old tool. When we had MSN Messengers, MSN Messenger is no longer there, but Microsoft does or did have a Microsoft Message Analyzer tool, which they have stopped development since 2015. But that's another tool that is specific for Microsoft operating systems from Microsoft that can be installed to gather more information. Then you've got EtherCap, which is a tool to launch man-in-the-middle attacks, data capturing, and is essentially a Linux command line based tool. Then DSniff is another password and network capturing tool which can help you capture data packets, prominently a Linux tool. Same with Iterate. This is a graphical tool which will allow you to capture data traffics and map protocols and identify which IP addresses have been communicating with what. Essentially, all of the tools have similar functionality, except that some have additional functionality like launching man-in-the-middle attacks or capturing or having specific filters that will help you identify and troubleshoot some network issues that you may be facing. Moving on to the next question, what is an operating system? Now, this is a very difficult question to answer because we normally, when we want to answer this question, we start off with the functionality of an operating system, right? We try to describe what Windows does or what Linux does or what Mac OS does, and then we are trying to figure out what an operating system is in the first place. But an operating system essentially, as the slide says, is a software program that provides a platform for computer hardware to communicate and operate with the computer software. So it is basically an enabler for human interaction with the hardware that you have. If you take the operating system out of the question, it's just some hardware which cannot interact with you. But essentially, when you have an operating system like Microsoft Windows or Linux or Mac, you're essentially installing an instruction set on that particular device, which will allow you to interact and manipulate the hardware to do whatever you want that hardware to do, right? Essentially, when we talk about drivers for your various devices, like a driver for your LAN card or for your sound card or for your graphics card, which allows you to tweak these cards for functionality, right? It allows us input and output functions. For example, the basic example, you open up Microsoft Office products like Microsoft Word or Excel, and you get a GUI on the screen, which you can interact with. You got a keyboard and you type on that keyboard, and the computer knows what you're typing and reflects those actions on the screen by showcasing it on that particular Excel file or a Word file. So how does the computer know what to do or what you're exactly intending to do at this point in time? It is all the operating system that is providing you all these services, analyzing what your inputs are, and then based on the programming, it is going to execute that and show it to you on the screen, right? Some of the most commonly used operating system are Microsoft Windows. You have them in desktop as well as server variants. Unix, Linux, again Linux as desktop and servers. You got Ubuntu in Linux, Red Hat, and so on and so forth. And then you got Mac OS for Apple related components. The next question, what is the difference between microkernel and macrokernel? Now the first thing we need to know is what is a kernel. Kernel is the heart of the operating system that allows that input and output to happen. It allows those drivers to be set up so that the hardware can interact with the software, and we can then instruct the software and the hardware both to function in a particular manner. So there are two types of kernels, microkernels and a macrokernel. Macrokernel is something that we normally use. Microkernels are for operating systems that use processes directly handled by the processor. The microkernel is very small in size. Macrokernel is large because it basically is the entire image of the operating system. The execution for a microkernel is slow. The macrokernel is going to be faster because it is more evolved. There's a lot of programming involved. Extendability, microkernels are easy to extend. Macrokernels are hard to extend. As far as security is concerned, if a macrokernel crashes, it takes everything down with it. The entire operating system is going to crash. But in case of a microkernel, it is only that particular process that is going to get affected. Microkernel, there is a lot of coding involved. Macrokernel, less coding is involved. Examples of microkernels would be Symbian OSs, most popularly used on yesteryear phones, Nokia's if you remember those, QNX and so on and so forth. Macrokernels, your Linux or BSD operating systems essentially use macrokernels. Next question, what are the different types of operating systems? So as you can see on the screen, 5 types of operating systems: batched OS, distributed operating systems, time sharing, multi-program, and real-time. What are batched operating systems? The computer operator places the jobs coming from input devices into batches. So consider this not from a desktop perspective, but from a server perspective, where these devices are used by organizations to compute and to crunch some processes that is going to make some business sense out of it. So when there are multiple processes coming in, multiple jobs that are going to be scheduled, a batched OS is going to place these jobs in batches, and they're going to crunch those based on the inputs that have been given by these operators. Distributed OSs, where there are multiple computers which are interconnected and are communicating through networks. So in a corporate environment, you don't use one single computer to do everything. You got a data center, and the data center will have a cluster of servers where they're going to share some resources to crunch one particular task, right? So that's where your distributed OSs come into the picture. Then you have time sharing OSs, where you are renting some time. So time sharing OSs minimizes the response time. Example, in today's world, cloud, right? You go onto the cloud, you have a virtual service over there. You schedule something, you schedule a job over there, it is executed, and for that time being, that operating system services your particular request and provides you that particular job. Any application that you see online that is executed, for example Facebook, from a consumer's perspective, could be a time shared experience. Then multi-programmed OS, the operating system uses CPU scheduling to separate jobs. So you're scheduling the CPU to complete certain jobs in this particular manner. And in real-time OS, the operating system gives maximum time to critical operations. So it identifies the priority of these operations. It knows the high priority items, the medium, low priority items, and based on that, it is going to execute these critical operations and get the job done. Moving on to the next question, what is the difference between logical address space and physical address space? Now, when you're looking at address spaces, this is where applications come into the picture, and when you execute an application, it is going to create a particular address in the memory where it is going to create a buffer to store its own information so that it can be provided to the processor, processed, and then can be returned back to the application as an output, right? So As far as definitions are concerned, a logical address is generated during running of an application or a program. A physical address is a physical address or a physical location on the memory module itself, right? Visibility, you can view a logical address because it is programmed into a computer. So if I'm looking at C++, and I'm using malloc or memory allocation, that's where the logical address is going to be created, where a buffer is going to be created for that program, and whatever the user input is going to be, it's going to be stored in that buffer. But whereas physical address is concerned, this logical address will be created on a physical store or a physical memory module, which will have its own addressing mechanism. Thus, you can see the memory module, but you cannot see the specific address on that particular memory module. But as far as a logical address is concerned, while you're programming or you're debugging the application, it will show you the logical address that has been created, the start point and the end point of the logical address that has been created for that particular program. It can be shown in a debugging environment, right? Address space, logical, and physical address is physical, like I discussed, it's the memory module itself. You can access only the physical address on that particular memory because logical addresses can be viewed, but you cannot access them physically. Generation, the logical addresses are generated by the CPU during the processing time, whereas physical addresses are computed by the memory management unit or the MMU that you have on your computers. And as far as logical addresses, they will always be, they are variable, whereas the physical address is always going to be constant. Looking at the next question, what is the difference between logical address space and physical address space? So moving on from the previous question to this, the logical address is an address created by the CPU for the processes that need to be addressed and that need to be stored as a buffer in the physical memory. Whereas the physical memory itself is going to be an address that is going to be there on the physical part of that memory, which is going to be assigned to it by the MMU. Then the next question discusses shells. So what shells are used in Linux? Now, what is a shell? Shell is the command line interface that we utilize on a Linux machine. So the terminal window, as we call it, is a shell. And there are different variations of a shell based on what Linux operating systems you're using. The desktop operating systems that you use or the server operating systems in today's world that you're going to use normally will always have a bash shell, which is the first shell that you see on the screen. Known as a born again shell, it is a default for Linux distribution. So as far as end consumers, regular consumers are concerned, it is always going to be a bash shell, a born again shell that you're going to utilize for scripting and to execute regular commands. But when it comes to high level programming, or it comes to specialization tasks, then you got the rest of these shells that you can utilize. For example, the KSH, known as a Korn shell, is used for high-level programming, which supports associative arrays and built-in operations. The CSH, or the C shell, has different functionality like spelling corrections and job controls. The ZSH, or the Z shell, provides unique features like file generation, startup files, and Fish, friendly interactive shell, which provides features like auto suggestions and configuration. So all of these have different functionalities depending on what usage that you have for that particular shell. The most common shell, like I stated, is the bash shell that you'll always come across in your desktop Linux operating systems. Then looking at the next question, what are the process states in Linux? Now, what is a process? Process is basically a service that is running for a particular application, for that application to function, right? This process is going to direct user input to the processor, process it, get that output back to the application, execute it, and then show it onto the graphical user interface for the user. So in Linux, there are 5 states for a process. First is the ready phase. Now in ready, in this state, the process is created and it is ready to run. So it is waiting for input. It's ready. The application is executed. The running is when the process is being executed itself. Blocked or wait is when user input is being looked upon. So it's waiting for user input so that it can do the processing. Completed or terminated, it has completed its execution or was terminated by the operating system for some reason or the other. So this is when things have, the processing has been completed. And then last state is zombie, where the process is terminated but the process table still holds the information. Maybe it is waiting for the kill request before it gets terminated. So these are the 5 states for a Linux process to be in. And that brings us to the 10 questions in the operating system and application space. In the next video, we'll be looking at 10 more questions on cyber attacks. Interview questions based on cyber attacks. Let's start off with the first one. The first question is, what is SQL injection? SQL stands for structured query language, which is a language that is used by most of your databases or your relational databases. The variations of your database would be MySQL, Microsoft SQL, Oracle SQL. You'll have IBM databases. All of these databases utilize the structured query languages to interact with the applications. Now, all of these databases have their own syntax, so you'll have to study most of these databases based on which applications and which databases you want to provide security for. But as the name suggests, SQL injection vulnerability or a structured query language injection vulnerability is where a user can maliciously inject a SQL input or a SQL statement in a query and send it to the database and evoke a response out of it. So this vulnerability is not specifically to the database. The vulnerability lies more in the application and the coding of that application. So when the application receives a query which it needs to be forwarded to the SQL database, we need to configure at the application level of what queries are allowed and what queries are not allowed. So there are different various aspects of how to manage a SQL injection vulnerability. But the basic flaw lies in the application where invalidated input is accepted and sent forward to the database, where the database might confuse it into an executable statement and thus create a response that was not warranted. There are various types of SQL injections as shown on the screen. In-band SQL injection, where you can look at an error-based or a union-based injection. A blind SQL injection, where it is either Boolean-based or a time-based attack. And then an out-of-bound SQL injection. Essentially, you're looking at databases and you're looking at application security, where you want to encourage secure coding practices so unvalidated input is mitigated. The next question is, what is spoofing? Now, in spoofing, you're basically assuming the identity of another person. So here the attacker pretends to be some other person or an organization and sends you an email that appears to be a legitimate email. It looks almost genuine. It has been constructed to replicate what a genuine email would have been, and it is very difficult to spot a fake one. There are different ways to identify whether an email is genuine or not, but that's for a different video. Moving on to the next question, what is a distributed denial of service attack or a DDoS attack? Now, generally a denial of service attack is an attack where legitimate users are prevented access to the resources that they legitimately can access, right? So, for example, if it is a bandwidth-based attack, the attacker consumes the bandwidth of the network in such a way that there is no more bandwidth left for legitimate users to access the network. Now, a single device may not be able to generate that much amount of traffic to consume the bandwidth of a huge server. Thus, the attacker will construct a botnet, and through that botnet, they will launch a distributed denial of service attack to the target victim. Right? So, a botnet, there are two terms that we want to look at over here. The first term is a bot, and the second one being the botnet itself. Bot is a software that, once installed on a victim's machine, allows the hacker to send remote commands to that machine that will make it generate some activity. Once we have enough machines on which such bots have been implemented, the collection of these machines would be known as a botnet. So an attacker would then instruct this entire botnet to start generating data traffic to be sent to the targeted network or to the targeted server, which will then bog down the server, thus crashing it and preventing users from accessing that particular resource. The next question is how to avoid ARP poisoning or ARP. Now, first let's understand what ARP is. ARP stands for Address Resolution Protocol, which is a protocol used by computers to communicate over the network. Once your computer boots up, it starts a discovery process of identifying its neighbors. So if I'm in a particular subnet, my machine will proactively send out ARP requests, an address resolution protocol, to find out which other machines are within the same network and which are live. Once it sends out a query, a live machine will respond to that query along with its MAC address. This information is then stored in what is known as a ARP table or an ARP table on the machine's cache. So whenever my machine now wants to send out a packet to this particular machine, it will go to the ARP table, it will identify the IP address and the associated MAC address, it will print that onto the data packet as a destination IP and destination MAC, and send that packet across to the switch. The switch will then identify the MAC address and send the packet to the relevant machine that is connected to that particular switch. Now, to confuse the switch into sending it to a different machine, ARP poisoning attack is created. This attack is generally launched to create a man in the middle attack. Now, to prevent this ARP poisoning from happening in the first place, there are three different aspects that we can utilize. First, we can use packet filtering, which will filter out and block packets that have the same source address data. So you have identified some malicious IP addresses and you want to block out some IP addresses. So you're using a packet filter firewall where you have instructed the firewall to filter out certain packets originating from particular range of IP addresses. This firewall and this technique will then block those kind of packets coming in. Second, keeping away from trust relationships. Organizations will develop protocols that do not depend on trust relationships, and thus you want to keep this protocol away from there. Once you have created a trust relationship, these machines should not be sending out ARP requests to other machines in the first place. Since the trust relationship has been defined and these machines know whom to communicate with, such kind of protocols should then be disabled. Or you can use an ARP spoofing software. So there are softwares out there that will look for ARP spoofing and prevent that from happening in the first place. So if somebody has sent out a spoofed ARP packet, that packet will be picked up by this software and it will be mitigated. Network visualizers like Glasswire, antiviruses like Sophos, they have inbuilt capabilities of identifying ARP spoofing attacks and mitigate them in the first place. In the next question, we are going to discuss what is ransomware. Now, ransomware is a type of malware that blocks victims to access personal files and demands ransom to regain access. There are three categories. Before we go into the categories, let's just revisit what ransomware is. Let's start with the word malware. Malware is a malicious software that poses as a legitimate software but has a payload that will have a security impact on your machine. So in this instance, viruses, Trojans, all of these can be classified under malwares. So can ransomwares. A Trojan is a software that will give you a backdoor access to a particular device. A virus will do some destructive activity on that device. A ransomware will basically encrypt the data of that particular user on that particular machine, thus rendering that data inaccessible to the users themselves, and in turn will demand a ransom to provide access to that particular data. So the three types of ransomwares, the first one is scareware, which uses social engineering to cause anxiety or the perception of a threat to manipulate users into buying unwanted software. So this preys on the gullibility of humans, where you can see a pop-up appearing on your screen which can scare you into believing that you may have been attacked or there is a virus on your machine, and then instructs you to download a particular software to mitigate that particular virus. Now, the malware will be in this software that you will be downloading, and then a ransomware will be installed and your data will be encrypted. Screen lockers, where locking users' computers by preventing them from logging in and displaying an official looking message. You will see a screensaver once you boot up, which prevents you from accessing the login page. So it will not allow you to log into your own machine, but it will give you a warning that your data has been encrypted and you need to connect to a particular email address and send bitcoins over there to get a decryption key to access your own data. And then the encrypting ransomware displays a message demanding payment in return for the private asymmetric key, which is needed to decrypt the symmetric keys for encrypted file. So once your files have been encrypted, you might just have a blank screen in front of you where you'll receive a warning message where it instructs you to pay up a ransom in bitcoins or in some cryptocurrency to some particular digital e-wallet which is not traceable. And once you make that payment, they will send you the decryption key and then you can access your data.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Then talking about the next question, what is the difference between an active and a passive cyber attack? Now, when we talk about cyber attacks, cyber attack is activity that is caused by a malicious user who wants to try to get access or do some security incidents on the victim's devices. So there are two ways that can happen. It's either in an active manner or a passive manner. In an active manner, the intruder attempts to disrupt a network's normalcy, modifies data, and tries to alter the system's resources. So this is more active, where the attacker will proactively try to destroy the network so that communications fail, or they might try to modify the data where we're using a ransom where they can encrypt it, or they might delete that data using a virus, or steal that data using a Trojan, or they might even alter the data so that it is no longer trustworthy. Whereas in a passive attack, the intruder intercepts data traveling through a network. Here, the intruder eavesdrops but does not modify the message. So they're just listening in, they're just observing what is going on. They're not manipulating the data, they're not stealing anything. It's just that they are monitoring the activity that's going on. Then the next question, what is a social engineering attack? Now, social engineering attack is a people-based attack. The victim here is the human by itself. The vulnerability also lies in the human. It may be executed through a computer, but end of the day, the gullibility is of the human. So it is the art of manipulating people so that they end up giving up confidential information. Now, we always read in the papers where somebody got manipulated, their passwords got hacked, and somebody's life savings got wiped out, right? Because they shared the OTP with someone or they shared the password with someone. Now, creating a scenario where these people will fall prey to this attack and share this kind of personal information to unknown people, that is where the social engineering attack comes in. Creating that scenario which will ensure that these people give out this confidential information. Now, there are three categories in this attack. The first one is a phishing attack, second is a spear phishing attack, and a third is a veiling attack. Now, phishing attack is basically a generic attack. It is targeted to the world at large. Whoever falls prey to that attack will be a victim. Whereas a spear phishing attack is a targeted attack towards a specific individual or a group of individuals or towards an organization. So there is a lot more research that goes into spear phishing, where you analyze the victim, you try to figure out what their vulnerabilities are, and you tailor make or you customize the attack to that particular vulnerability. Once you have that attack, you launch it against those people will then fall prey to this attack. And a veiling attack is where you're attacking top level executives. So the C-level executives of an organization, politicians, movie stars, wealthy and powerful people. So any of these people, when they're attacked, it will be known as a veiling attack. Next question, what is man-in-the-middle attack? Now, this is something that we had touched base when we talked about ARP, where the ARP poisoning attack needs to be executed to leverage a man-in-the-middle attack. Now, in the man-in-the-middle attack, the attacking computer takes the IP address of the client. Unaware of this, the server continues to communicate with the attacker. Now, if you remember in a previous question, we have also talked about spoofing. So in this scenario, attacker has spoofed their IP address to replicate themselves as a genuine client. And now with that spoofing in mind, they might either through a R poisoning attack or just because of the spoofed IP address become a man in the middle. That means that they are now eavesdropping on the conversation between the actual client and the server by posing themselves as a server. In this scenario, the attacker is now a go-between between the client and the server and can eavesdrop and can copy the data. If they want, they can modify the data as well. So as you can see on the screen, the attacker becomes man in the middle, which means that they are now eavesdropping on the conversation that is happening between the client and the server. The next question, who are black hat hackers and white hat hackers? The main thing is the differentiation between a black hat hacker and a white hat hacker. Now, black hat hackers are skilled individuals who illegally hack into a system. The motive behind such an attack is mostly for monetary gain. These individuals are also known as security crackers. Now, if you look at your criminal hackers, those who have malicious intent, those who do hacking for the intent of personal gain or for the a matter of disruption. The main thing that black hat hackers lack is authorization. They are not authorized to do the activity that they are about to do, and they are going to get unauthorized access to devices or to data, which is going to cause losses to the organization involved. Whereas on the other side, a white hat hacker are also known as ethical hackers. These are the individuals who discover vulnerabilities in a computer network, and they help the organizations mitigate these vulnerabilities. They help the organizations defend themselves from black hat hackers. So the main difference between these two types of hackers, a black hat and a white hat, is the intent and the authorization. So black hat hackers will have malicious intent. They will try to personally gain from that attack by finding out vulnerabilities. They also will not have authorization to conduct whatever activity they are doing. Whereas on the other side, white hat hackers will be hired by organizations. They will provide authorization for certain activity that the white hat hacker can do to find out those vulnerabilities. Once those vulnerabilities have been found out by the white hat hacker, they will report it to the management and guide them in implementing security controls to mitigate those vulnerabilities. The main difference between a black hat and a white hat is the authorization and the intent. The next question, what are honeypots? Now, honeypots are a very interesting device that can be introduced in a network. These basically are decoy servers that are implemented in a network to attract the attention of an attacker. It is there to lure an attacker into attacking that particular device, thus creating a security blanket for the rest of the devices. So if an attacker has been able to bypass a firewall and is now trying to scan a particular network, when they scan, they will come across various devices that are there in the network. They will then proceed to do a vulnerability scan on these devices. The honeypot at that point in time will provide as prove as an attraction to these attackers, because it will demonstrate some vulnerabilities to the hacker which will divert their attention. So these vulnerabilities are simulated on these devices. These actually do not exist. But the moment the attacker then starts interacting with the honeypot will identify that as a malicious traffic and will warn the administrator about a possible attack that is going on. The administrator will then investigate through the honeypot of what activity is going on and then reconfigure their security controls to block the attacker or mitigate the attack itself. Right? So it is more of a decoy server that will showcase or simulate some vulnerabilities to an attacker, thus to lure them and safeguard the rest of the network. These are the 10 questions for cybersecurity. In the next video, we'll be talking about cryptography. The first question, define cryptography, encryption and decryption. Now, cryptography is used by security professionals to scramble data into non-readable format, which is used in securing that information. So it involves converting data from a readable format into a non-readable format and then reversing it back to readable format again. For example, the word computer is now scrambled into looking like an unreadable format. Now, if you look at this word that it has been scrambled into, it would be very difficult for a human to figure out what the actual word was. Now, in this scenario, we have taken an algorithm where we have made a shift of the alphabet, where we have added 2 alphabets to the current one. So C plus 2 becomes E, O plus 2 becomes Q, M plus 2 becomes O. So we have done a shift of 2, and thus the key over here for this algorithm is the alphabet plus 2. So any person who figures that out will be able to unscramble this and convert this back into readable text. The fact of scrambling a readable text data into something that is unreadable by using a particular key is what cryptography is all about. Now, as we discussed, the decryption again is replacing the alphabet and taking it further back by 2 characters. So E minus 2 becomes C, Q minus 2 becomes O, O minus 2 becomes M, and so on and so forth. So anybody who knows this key, the shift key, anybody will able to decrypt this particular character. So this depends on the user. If I want to utilize alphabet plus 5, then the spacing, the shifting of that character will be the 5th character from that particular character, and so on and so forth. The next question, what is the difference between ciphertext and clear text? Ciphertext refers to the text which is encrypted and totally undecipherable. The message received after decryption is known as clear text. This text is comprehensible. So the word computer is clear text. That means that it has not been treated to any cryptographic measures. It does what it is intended to be. However, if the moment we encrypt it, that means we scramble it into unreadable text by using any of the algorithms that we'll be looking at, that text is known as a ciphertext. And without the key, this becomes unreadable. The clear text, as discussed, is the plain word that we have utilized. We are using the English language in this instance. So the plain word computer is the clear text. Once we add the encryption layer to it, we get the ciphertext to it. Moving on to the next question, what is a block cipher? This refers to the method of encrypting the plain message block by block. The plain message is broken down into fixed size blocks and then encrypted. Now a block cipher is normally used for data that is stored. So a data that is stored on a hard disk and we want to encrypt that data, that is known as block encryption or a block cipher. So a block cipher is an algorithm that will allow you to encrypt data that is stored onto a hard disk. So in this example, we've got plain text which is 64 bits in size, and we have added a layer of encryption to it. So plain text plus the key that we have studied in the previous questions, and then the scrambled data out of it, which is unreadable and thus encrypted. Then the next question, what is public key infrastructure? Now the public key infrastructure is a set of policies which secures the communication between a server and a client. It uses two cryptographic keys, public and private. So the infrastructure itself is a set of policies, people, procedures, and techniques which are standardized in nature and are globally accepted, which allow us to use digital certificates to encrypt data and decrypt the data at the other end. We use asymmetric encryption over here, which means that we use two keys. One is a public key to encrypt and the private key to decrypt. The other part of encryption is asymmetric encryption, where the same key is used to encrypt and the same key is used to decrypt. Now in a public key infrastructure, like I said, we have standardized that. So in the standardization part of it, these are the various players that have been defined in the public key infrastructure. The first is the user or the sender in this scenario, the one who requires this digital signature to digitally sign a particular transaction or a communication. A registration authority with whom they are going to register for that particular key, the certification authority who issues that key, the verification authority who validates the key itself, and the recipient who is going to be the other party of that particular transaction. So how is this utilized? A sender or the user who requires this digital signature will request or apply for a digital signature with the registration authority. The registration authority would validate the genuinity of the user. So they might do some identity verification or proof of residence or something like that. Once they've identified the person and they have validated the information, they will then send the request to the certification authority stating that the sender has been validated, and the certification authority can issue the digital certificate to the particular user. They will send the public key to the sender, which will be utilized by the sender for further transactions. So when the sender is going to sign some data and wants to send it across to the recipient, they will use the public key to sign it and send it across. The recipient will then validate with the verification authority to see if the signed data is correct or not. Now, while the certification authority sends the public key to the sender, the certification authority updates the private key with the verification authority. So whatever is signed by the sender, received by the recipient, and they want to validate it, they will send it back to the verification authority. The verification authority will validate using the private key. Once the private key is validated, it will then send the OK signal back to the recipient, thus allowing the validation of that particular transaction. If the signature is tampered with or is not, the verification authority is not able to validate the signature, it will then send a denial message back to the recipient and the transaction will not go through. So the PKI enables trusted digital identities for people. So the PKI grants secure access to digital resources based on the infrastructure that has been created, and the core of the PKI is a certification authority which ensures that the trustworthiness of the digital data is ensured. So going back to the previous slide, these are the key players that have been standardized in the public key infrastructure. The certification authority is the authority that issues the digital certificates. The validation authority is the one who validates that digital certificate. Moving on, what is RSA? RSA is one of the first public key crypto systems that is used for secure data transmission. It stands for Rivest, Shamir, and Edelman. Now, these are the three people who have created this algorithm: Ron Rivest, Adi Shamir, and Leonard Edelman, who are the inventors of this technique. It is an asymmetric cryptography algorithm which works on both public and private keys. Hence, the encryption key is public and the decryption key is kept private. Now, as we have discussed earlier, symmetric and asymmetric cryptography. Symmetric cryptography is where the same key is used to encrypt and decrypt, whereas asymmetric cryptography is where there are two keys to encrypt and decrypt the algorithm. What are the few alternatives to RSA? Now, RSA is an algorithm that is used for encryption. There are a lot of other algorithms that can be utilized to alter or to scramble data depending on your requirements. So in the previous question we have studied and we have talked about what RSA is. It stands for Rivest, Shamir, and Edelman, the three creators of that particular algorithm. But there are a lot of alternatives to this algorithm depending on how secure you want that data to be. And some of them are listed here on your screen: Duo Security, Okta, Google Authenticator, and LastPass. LastPass is a password manager. So is Duo Security. Google Authenticator is something that we all utilize. It is an application that we can download and store on our mobile devices. And we can set that up to authenticate ourselves with certain portals. So it issues a unique ID to us, which once utilized will allow us access to those particular portals. Okta is an identity manager where you have created different digital identities and you have assigned them certain permissions, and based on your authentication mechanisms, Okta will allow or disallow access to those different applications or different portals as you have configured it. So all four are authorization and authentication mechanisms which can be used as alternatives to RSA.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Next question, what are the prime objectives of modern cryptography? And this is a very important question because we've so far looked at what cryptography is and what public key infrastructure is. But what is the achievement out of it? Why are we utilizing it? And what do we want to gain out of it? So the main and the prime objectives of modern cryptography are as follows, mentioned on your screen. The first one is confidentiality. The second one is non-repudiation. Third one is authenticity. And the fourth one is integrity. Now, if I go back to the first one, confidentiality, that is where I want to keep data confidential. That means it will only be visible to the authorized users, right? So here I have created a list of people who have deemed as authorized users and have created a digital identity to them and have given access controls to those people. Now, that is how confidentiality is ensured. So when we want to keep data confidential, we create a list of users who we are going to allow access to certain resources, and we are going to define what access controls are to be utilized, what access are allowed, whether they've got administrative access or user level access, and only those authorized users are going to be able to access these resources. That is how we maintain confidentiality. The next one is non-repudiation. Non-repudiation is the prevention of denial of having been a part of a particular transaction. So in the public key infrastructure that we discussed, where a digital signature was utilized to sign a particular transaction and then sent to the recipient, the sender would not be able to deny of having originated that transaction because it was using their digital certificate. Thus, non-repudiation comes into the picture. One more example that we can have here is on our mobile phones when we use SMS, short messaging service, and we send a message to another person. The person, when they receive a message, the number is validated by the service operator, and thus the sender cannot deny having sent that message. The sender at the same time can have a delivery report sent to them that the message was delivered to the inbox of the recipient, and thus if the recipient denies having received that message, the delivery report becomes proof of having that message being delivered to their inbox. Thus, both the parties cannot deny of being a part of that particular transaction. Then comes the part of authenticity. Now, in confidentiality, we have created a digital identity, assigned it to a particular person, and we have given them digital signatures where they cannot deny having been a part of that transaction. But authenticity is the part where they try to prove that they are who they claim to be. So if I am claiming a digital identity, I have to prove that I am that person who I'm trying to claim to be. And an example to that is when we go to our gmail.com websites, it first asks us what is our username. Our username is normally our email address, which identifies the account that we are trying to access. Right? So this account is confidential because it is only authorized for a particular person. And once they identify themselves by identifying the email address, that's when the authentication part comes into the picture, where it asks for the password. Now, it has never ever happened that we just go on to the gmail.com, type in a password, and then it figures out which account we are talking about. So the first step is always the confidentiality part, where we identify which account we are talking about, and then we try to authenticate as the owner of that particular account by providing the appropriate password to that account. If both of these match, only then do we get access to that account and we are able to make whatever transactions we want to make. Now, when we are making those transactions, non-repudiation comes into the place where all our activities also being logged. So we have identified our account, we have authenticated ourselves by providing the password. So the proof is there that it is us who are trying to access it. And then whatever activity we do, send an email, receive an email, delete something, attach something, all of those activities are logged and stored as proof of what actions have been done. So tomorrow, if we deny having sent that email, Gmail can still prove to us through those logs that that activity was done by us. And the fourth part is integrity, which ensures that the data received and sent by the sender and received by the recipient has not been modified while in motion. So the integrity part is the trustworthiness of that data, that the data has not been modified by any hacker or any other entity and is still trustworthy. So these are the four prime objectives of modern cryptography. Once I have scrambled that data using my public signature, it is only my private signature that is going to decrypt it, right? Using these mechanisms, I will be able to achieve all these four aspects of cryptography and security. Next question, what is Safer? Now, Safer stands for Secure and Fast Encryption Routine, which is also a block cipher. As we have discussed previously, block cipher is a cipher that is used to encrypt data that is stored. So it has a 64-bit block size and byte-oriented algorithm. Safer's encryption and decryption procedures are highly secure. This technology is widely used in applications like digital payment cards. So when you're using a digital payment gateway to make transactions, so you have gone onto an online portal, you want to purchase a particular item, and then it takes you to another payment gateway where you have to fill in your credit card information, sensitive information like your expiry date, CVV information, and then the OTP or the password that you have created for your particular account. Now, all of these need to be secured or highly secured based on PCI DSS, which is the payment card industry data security standard. So these standards ensure that certain protocols are utilized to attain that level of security. Safer is one of those block ciphers that is used under the digital payment gateway infrastructure. Next question, how does the public key infrastructure work? Now, we have already discussed this in the previous diagrams. We have identified the key players, the certification authority, the registration authority, the end user who requires the digital certificate, the validation authority who's going to validate it, and then the recipient, the end user with whom the transaction is going to be conducted. So the first point here is the request for the digital certificate is sent to the registration authority, they validate it, and then they OK to the certification authority, who then process the request, and the digital certificate is issued to the person who has requested it. So when the person wants to conduct that transaction, they use that digital certificate to sign that transaction with the end user. The end user validates that with the validation authority, and once validated, the transaction goes through. And now the last question, what is the blowfish algorithm? It is a 64-bit symmetric encryption algorithm. So this is an algorithm that uses the same key to encrypt and the same key to decrypt. The same secret keys used to encrypt and decrypt the messages. Here the operations are based on exclusive ORs and additions to 32-bit words. The key has a maximum length of 448 bits. Now this is a little bit technical. You might not want to go this technical in an interview question. You just need to identify what the algorithm is used for. So whether it is a symmetric algorithm, which means it uses the same key, or a asymmetric algorithm where it uses a public key to encrypt and a private key to decrypt. Thus the blowfish algorithm is just one more algorithm which uses symmetric encryption to encrypt and decrypt data. Algorithms that we have seen, RSA and others that we have discussed. As far as the interview questions are concerned, what we need to remember is which algorithms are symmetric, which algorithms are asymmetric, what do symmetric algorithms do, and what do asymmetric algorithms do. And we also look at block ciphers and stream ciphers. Block ciphers are utilized to encrypt data that is stored, stationary data, data at rest, and stream ciphers are utilized for data in motion while they are being streamed. So SSL and TLS is another algorithm that comes into the picture when we are looking at streaming data. That's it for this particular video. I'll see you in the next. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.